Hey, y'all. I just want to make sure that everybody has a good understanding of this activity that we're doing. So, this is radiometric dating. Okay. So, um, over time, elements go through radioactive decay. Okay. And they break down. And sometimes when they break down, they create new elements. Scientists know how long it takes for them to break down to half their amount, and that's called their half life. And so, for example, with carbon 14, you are full of carbon 14, so am I, so is every living thing. Okay, once those living things die, immediately the carbon 14 starts to break down. And the half life is 5,730 years. So, after 5,730 years, half of that carbon 14 will have turned into nitrogen 14. And so the same thing, uranium 235 turns to lead 207. That takes 710 million years. So that's how they age much older items. Potassium 40, it breaks down to argon 40, and that takes 1.3 billion years. So that's how they're dating extremely old. And then even rocks they can do this with. So this activity down here, you're going to be looking at half-life. So I want to show you this little, I made up a practice one. So it's the same chart. Okay, we have carbon 14. We're going to draw a picture showing two half-lives taking place in a fossil below with 12 carbon 14 atoms. Okay, so after 5,730 years, you have to always think in terms of that. So its first half life, what I'm going to do is I'm just going to copy these. So I'm going to end up with 6, right? Because that's going to be half of it. All right. And then half of it will have turned to nitrogen, right? So the nitrogen, oops, sorry, everybody. There'll be 6 of those. Okay. Then the second half life. After the second half life, half of these carbons will have changed. So again, we're going to end up with half the carbons. So, oops. And then the other half will be replaced by nitrogens. And you guys understand that I couldn't draw those bones. That wasn't really going to work. That's to a second half-life. So then how many carbon 14 were left after your first half-life? 6 of them. How many after your second half-life? 3. Using the chart above, how many years old would scientists say the fossil is after its first half-life? That would be 5,730 years. After its second half-life, we would double that, wouldn't we? So 5,730 times 2. Oops. Okay. So that's the first activity, and you'll be answering the questions. The second activity is this one. Sorry, let's see. Where you're going to be looking at relative dating practice. And so here you're going to just be looking at these fossil layers, and this is pretty similar to what we've done in the past, looking at relative dating. So that's it. Thanks.